Here we are on the day four. Well, it's not technically going day wise, but we are on the part 3.2, I guess. And it should be 3.2. I wish it's gonna be 3.2, but it's late at night. I can't assure that. And let's see. So I haven't structured a lot in our series that how I'll be teaching or how I'll be reading this. So we'll be reading the blog by Philip. This Rust. Yeah, there it is. So we'll be reading this. Uh, this is how we're going to build our OS in Rust. It's a good blog written by Philip, and it's very known, but it's quite old. Was dated back to 2018, I guess. Yeah, Feb 2018. So it's, I guess, how do you calculate 2025? It's quite old. It's literally more than 7 years old. But they have updated it to Rust 2024, so we can just go through it now as well. So let's. I'll be reading the blog, and if I understand something, I'll teach you too. That how you can understand it more in shape. It is better to read along with this, because why do you need to just yeah? Why do you need to read it alone like me when you could have a partner who doesn't understand shit? Yeah, it's more easier to rant someone else who is dumber than you. Let's not go more specific in that. I have my black coffee with me. Is this black tea or I don't know. It's just coffee and water. I don't know how do you say it. And let's start. So we were on the VJ text mode chapter, and let's just go inside our log. I'm using VS Code, and we have set up the whole environment in the first blog only. So yeah, you can follow along with that. I just delete it now. I guess yeah, we have completed it to we weren't able to print this due to some sort of Ubuntu error. Let's see if it's fixed now. Cargo build, and then if I do this, this should run. This should run some sort of that. Yeah, so it's printing now. I guess we just needed to restart and it's done. So GG's, we have completed till the hello world. Now we can understand what's volatile and maybe complete it today only. Completed by today or completed by 10. As instantly visit from here. And let's go. So what's volatile? We just saw that our message was printed correctly. However, it might not work with future Rust compilers that optimize more aggressively. What will not work? Our printed message. Okay. The problem is that we only write to the buffer and never read from it again. The compiler doesn't know that we really access VJ buffer memory instead of normal RAM. So compiler doesn't know it's VJ buffer memory. It is comparing it to the normal RAM that the compiler could access, but it's a buffer right on the screen and knows nothing about the side effect that some characters appear on the screen. And it doesn't know about the side effects like we got that two boxes. Why did we got two boxes for one that one weird O? One weird O in here, right? One weird O. No, yeah, we did it here. So one weirdo gave us two boxes because it is represented by 2 bytes in UTF-8. Okay, so now We can do so what we can do with volatile. So it might decide that these rights are unnecessary and can be omitted. What these erroneous optimization? What it's erroneous. So erroneous means no error optimization. We need to specify these rights as volatile. Sorry for that. So we it might decide that these are that we need to specify these rights as volatile. This tells the compiler that the write has side effects and should not be optimized away. So this will explain that it would have side effect. It is implemented like the unsafe Rust we write. So you don't understand Rust in this blog, but you understand to write unsafe Rust. That's I have kind of gone through. I don't know how it would help us in accelerating in our career, but let's see. I would obviously understand how an OS works after this. That's my way of starting the blog. It was never to understand Rust better, it was to understand the operating system, the underlying shit I use. In order to use volatile writes for the VJ buffer, we use the volatile library. This create this is how packager yeah, I know that, I'm not that dumb. This create provides a volatile wrapper type with read and write method. So with the volatile library, we get the read and write methods. What does these method do? These methods internally use the read volatile and write volatile functions of the core library and thus guarantee that the read and writes are not optimized away. So when we are doing the read and write methods now, it will be using the volatile method. So we can just change it in our read and write functions, but we don't read, we just write till now. I guess I'm just taking my sips of coffee, so if you don't mind that. Nice. We can add a dependency on the volatile crate by adding it to the dependency section in our cargo.com. I love it. So what the fuck? It's quite old package. I have never used 0.26 or something like this packages. Literally, I haven't used those. It's updated. Or used 26, 12, 7, something like that. Make sure to specify volatile version 0.2.6 newer version of the crates are not compatible. Okay. So a semantic version number for more information. Yeah, I get it. Let's use it to write a VJ buffer volatile. We update our buffer type as follows. So let's do it. We need to add it on top. Yeah, that's how I do it. Use volatile, and then we would have volatile from it. And where do we do add it? So now the struct buffer. Where was the struct buffer? It is. So now struct buffer has characters where the screen character is changed to volatile screen character, the buffer width remains the same. So we need to just wrap it the volatile buffer and it's easy now. So we just need to and what does it even do? Instead of a screen character, we are now using a volatile screen character. The volatile type is generic and can wrap almost any, so it's a generic. Screen character is now generic. And this ensures that we can't accidentally write it to normal instead. I don't understand this. This ensures that we can't accidentally write to it normally. Instead, we have to use the write method now. Oh, so we can't do a screen character sky character. We need to use screen character dot write or something like this. I don't know. Where did we write it? So here we implemented the byte function. So now we can't do these right. Now we need to Oh, yeah, we could now change it completely. We don't need to have this type over here. Just call the right function, pass this inside of it, and just wrap it inside of this. How does it work out of the box? There's nothing changed. There's something changed over here. Now the match byte doesn't. It has not line. No, it's nothing changed. It's just this. It's just so simple. That's very clean. So now we just change the screen character. We were just before that we were just saving it to the screen character and just writing this byte to the byte. The color code we were just giving the color code the struct we provided. But now we're writing right and then we are providing the values. That's causing volatile. Instead of a typical assignment using equals to, we are now using the right method. Oh, the coffee is cold now. It doesn't taste so good. We can guarantee that the compiler will never optimize away this item. Yeah, we can assure that. Let's come to formatting macros. Now we have completely save ourselves, save, I don't remember the correct tense of the words. Formatting macros. It would be nice to support Rust formatting macros too. Yeah, we read that last lecture that we will be implementing macros, formatting macros like println. Yeah, let's read it. Yeah, it's gonna be interesting part. That way we can easily print different types like integers and floats. To support them, we need to implement the core FMT trait. The only required method of this trait is a write string, which looks quite similar to write string method, just with a FMT result return type. Ooh, ooh. So implemented it. Where did we change it? So write string method is here. So now what do we do? We change the right string method completely. Now we just need to add the FMT. Now use core and FMT. What do we do now? Just completely modify this, the right string one, or we just create a new one. We need to create a new one. Let's create it over here. We have to implement FMT and write for writer. And in this, we have a new function, write str, which will have a mutable self and a string, which also is no, we have to assign a result type as well, which is going to be FMT, and it will have our result trait. Now we can just use the oh, so it wraps the right string function in right. Yeah, I get it. Yeah, it's clean code. We don't have to reload that again, but better if we would do that in one single function and not create two. It's written okay, everything is okay. It's nice. It's nice. Yeah, so if, of course, result requires an okay. Now we need to change the right string. Yeah, we just change it right here. We don't. Actually, we don't. Now we can use the Rust built-in write and write element formatting method. Uh, where do we change it? So let's look. So inside the print string, we can just call it over here. Use core and fnt. And what do we do? We need to implement write. Let's remove it from here. I don't like to write all those traits. I like to use them on top of the line on the page. Ah, so we have implemented this. Now with the writers mutable struct, everything is the same, looks the same. Now, oh, now we're using the right macro from the it's all small and it is using writer and this is the numbers of this and this. What the hell? And we using unwrap. Why do we use unwrap? Yeah, it's look all done. So what are we doing? We're just this is integer, this is float, and we're using unwrap to unwrap all of this. How do we use unwrap? Now you should see a hello. The numbers are this. I just printed. Then you do cargo build. And so that's cargo one. Yes, yes, that was quick. So how did that happen? The right call returns a result which causes a warning if not used. So we call the unwrap function on it, which panics if an error occurs. Oh, so we haven't implemented the error type for the Rust for the result. So we are using unwrap, which does that for us. So we know when the function panics, we can just push back or stop all of the write operations, I guess. This isn't a problem in our case since writes to the VJ buffer never fails. Yeah, that's why we use the buffer. If we do this close, this stop, yes, it does. New lines. So we have completed two topics, volatile and implementing the formatting macros. Yeah, yeah, we've done these. We can implement more. I would love to implement more. So let's go to new lines. How we will dealing with new lines? So they have kind of shaped it better. Now new lines. Right now we just ignore new lines and characters that don't fit into the. Am I recording? Yes, I am. Right now we're just ignoring the new lines and characters that don't fit into the line anymore. Yeah, we're doing that. Yeah, is new line. We haven't created the new line function. Why are we doing that though? Instead, we want to move every character one line up. The top line gets deleted and the start at the beginning of the last line again. What the hell did I just read? Right now, we just ignore new lines and characters that don't fit in. Yeah, we did it over here. That don't do it. We just do this. Right, the box. Uh, where did you handle it? This was for the new line, right? We just shifted to a new line. We will implement the new line function. Instead, we want to move every character one line up. The top line gets deleted. We are starting from the down the below the most bottom of the screen, right? So as we hit a new line, we just shift to the move every character one line up. Yeah, we can do that. And the start at the beginning of the last line again. And the start at the yeah, I get it. To do this, what it's saying is we just go one line up and where did the last line end? We just shift it to the beginning of the new line. That's what they are saying. To do this, we add an implementation for the new line method of the writer. Cock is so bad. Ah, sorry for the inconvenience. Again, where were we? So yeah, to do this, we add an implementation for the new line method of the writer. Yeah, we haven't implemented it here. Now we could. It's inside the writer. So now for row in first, let's implement this. We have stated as a to do, but we now need to create this. What's this? If you're hearing, yeah, you're hearing the barking noise. It's my dog. Let me fix it. I guess the voice is now more clear. We were implementing the new line function. Let's just compare. We'll lead line by line. So it's creating for loop, which goes per row, and I guess same print from the top. It's just starting from the top. Buffer height, and now it's a nested loop. Uh, it's all my lead code knowledge, guys. Knowledge, knowledge as Indian accent. Ah, doesn't drop down when you work now? Well, I'm pressing the shift that's causing this issue. Yeah, that's that was causing the issue. Uh, let character, no, not the sky character. Let character is equals to self dot buffer dot characters. So it's all the same. Where I'll call the read function. Is it from the volatile? It's not from the volatile. It is self dot buffer. Self the buffer dot characters. I'm just not in my perfect writing position. So minus one, and there's the column. Column dot write, where we're passing the character. I understand it. Here it reads from the characters and just reads, and where the character is then passed to the new row. So now we just don't reach. So now as it reaches the buffer's width, we just access those characters and just simply pass it to the new line using the row minus function. Uh, Now we have to come out of the nested loops and clear the row, which is buffer height minus one. So this is for per row. You do this for per row, and you can now reach fill the buffer height and column reaches to the buffer width. Why is the row one? Can you do this? Because we already are on the first row and we don't call new line on the first row. Yeah, I get that is the question. That is the answer. Now the column position is zero. Yeah, as you shift to the new row. We have also implemented, yeah, it's to do, I guess. No, yeah, it's a to do. The clear row. Yeah, where did we yeah, we just use this function here. Clear row and itself, and now use the row, which is a U size, and it's to do. I don't know when we'll do it. What we did here is we iterate over the all screen characters and move each character one row up. Yeah. Note that the upper bound of the range notation is exclusive. Oh, so upper bound is exclusive, and we also omit the oath row. The first range starts at one because it's the row that is shifted off screen. Yeah. Uh, We just omit the zeroth row as I said to you, cause the first range starts at one, as were already on the zeroth row. That's why we use the first row, because it's the row that is shifted off the screen. Now, as we shift to the new row, the older row is shifted off the screen. That's what I'm getting from this. Let's see from the implementation what it actually does. To finish the new line code, we add the clear row method. Here is the clear row method. Clear row is the row that is getting the shifted off the screen using the clear row one. Let's see how do we do that. It's blank, so it's oh yeah, that's cheeky. That's very cheeky. We're just passing nothing, and it what it does, it makes it all empty. So it does it's just a space. The color code, it's self dot color code, whatever the color code was for the background, it is passed again. So it appears to be blank, but it has space for column in zero to buffer with. Now what is it for? Self dot buffer characters row dot. Oh yeah, we need to write it though. It's not implemented yet. So in self, we access the buffer and we access the characters, which is the buffer is actually 2D matrix where we write to it the blank reached. So here the clear row function is also implemented. This method clears a row by overwriting all of its character with a space character. Yes. So does it actually work? That's the question to be asked. Uh, let's first implement the global writer, the global interface, sorry. To provide a global writer that can be used as an interface for other modules without carrying a writer instance around. Uh, so we'll create another module, I guess. Instance around, we can create a static writer. So a static writer is like static in Rust is similar to static uh, in Java, I guess. Like oops, where static means the value of these won't change. The column position would always be zero. The color code will always be yellow and black. The buffer will always be this. So I suppose this is what they inherit or want us to do. Uh, where did we initialize like static? Yeah, down here we did that. So we just change it to static. We just do this. No, we don't. Where do I change it? I don't know. Where do I do it? So I think so. Which key on top? That's where we create the public static, and it's a writer which implements a writer, and the writer is now a struct, which is column position of zero. I just copy all this. It's understandable. We don't need to write it. Yeah, makes it look better. However, if you try to compile it now, the following error comes. Let's try to compile it. Start the build. The error is there that to the top. The error is expected this, but found this. Wait a minute. page. I'll do 31, 31, 31, 31, 31. 31 is here. Yeah, sorry for that. I fixed it, and now that is in 103. I need to add it over here as well. I don't know. After this, I'll do it. I don't know. Rust kind of became Java here. Now, yeah, now we are getting the same error as these. The color code you this calls in static are limited to constant functions, tuple structs, and variables. Tuple and struct and tuple variables. So yeah, statics are limited to functions and tuple structs and tuple variants. So we can't implement it on enums. Color code is an enum, right? Uh, color is an enum. Color code is a struct. Color code is a struct. We write the struct. Uh, no, no, it is color code. No, color code is an implementation. It's not a struct. It's the implementation of color code. It's a struct. Color code is a struct. Uh, it implements this. So what? How we can fix this? Raw pointers cannot be dereferenced in statics. Buffer unsafe. This dereference. Don't get this. I don't know why. So we can't dereference a raw pointer to constant in the statics. So we can't do anything in statics. Static requires immutable values, but we are passing an immutable pointer. And static requires immutable values, and we are again doing this. This is the same error. Yeah, this is the same error. Two different lines. To understand what's happening here, we need to know that statics are initialized at compile time in at compile time in contrast to understand what's happening here, we need to know that statics are initialized at compile time in contrast to normal variables that are initialized at run. Yeah, statics run before the main, right? So it's logically compile time and it's actually compile time. So the components of the Rust compiler that evaluates each initialization expression is called the constant evaluator. So its functionality is still limited, but there is ongoing work to expand it. For example, in the allow panicking in constants RFC. So there's some kind of work. I don't know how do we do it, how we deal it with now. The issue with color code new would be solvable by using constant functions. So we don't use struct here. We'll use the functions now, which will obviously fix this. But the fundamental problem here is that Rust constant evaluator is not able to convert raw pointers to reference at compile time. We will not be able to use pointers that way. Maybe it will work someday, but until then we have to find another solution. So statics won't work. This was here to explain why it won't work. So we would need lazy statics for that. Wait a second. We are so back. Let's start this lazy statics. The lazy statics. It fixes the statics that's normally used in Rust. So the one-time initialization of statics with non-constant function is a common problem in Rust. Fortunately, there already exists a good solution in a crate named lazy static. This crate provides a lazy static macro that defines a lazily initialized static. Instead of computing its value at the compile time, the static lazily initializes itself when accessed for the first time. So it works like finalize Mac, the finalize in sorry, the finalize in oops. That works something like that. If first exists, we just give it the values. It works like that. Thus, the initialization, yeah, so arbitrarily complex initialization code is possible. Yeah, we can just swap. Where did we write that code? Where we wrote it. So we do change it to what? We just add. Let's just add the dependency first. It's oh, you have to make a specific dependency for this lazy static, and under this, we write the version of this first, which is going to be 1.8, 1.8, and the feature is going to be what am I even doing, bro? Just, I just came back. So the feature is going to be spin no STD. What it is, understand what it does. So we need a spin no STD feature since we don't link the standard library. Oh, so it means don't spin STD, don't spin the standard library. That's a good feature. So it's already implemented in the lazy static. It's nice. With lazy static, we can define our static writer without problems. Use lazy static. It's quite good, great. Use lazy static, then lazy static. Thanks for that. Oh, now we wrap it inside the lazy static. It looks very much helpful. I probably would just use a macro here. So we'll wrap it inside the lazy static. Yeah, there. It's done after this. Hmm. Yep. However, this writer is pretty useless since it is immutable. This means that we can't write anything to it since all the write methods like mute self, take mute self. Yeah, we can't use it because it's static. That's not what static is for. Uh, yes. One possible solution would be to use a mutable static. What the fuck? But then every read and write to it would be unsafe since it could easily introduce data races and other bad things. Using static mutable is highly discouraged. There were even proposals to remove it. But what are the alternatives? We could try to use an immutable static with a cell type like ref cell or even unsafe cell. Oof, what the hell, bro? Super cold coffee is so bad, but it hits the same spot. Yeah, let's get back to the blog. So this provides interior immutability. What is interior immutability? The design pattern does that allows you to mutate data even when there are immutable reference to the data. What the hell? Is it possible? Normally, this action is disallowed by Boring rules. So it's unsafe for us then. Yeah, I told you before that you won't learn Rust from writing this blog. You will write how to write an unsafe Rust, which you will eventually know that it's unsafe, so you won't write in the Rust. Uh, yeah, that helps both ways, but it isn't the fastest way to learn Rust. But these types aren't synchronous. Yeah, because it's unsafe. Why would you need a synchronous unsafe thing? So we can use them in statics. Mhm. So yeah, it's still immutable. So what is spin locks? So does this help now? Spin locks. Our cargo thermal is getting heavier in this. We added volatile. We added lazy static. Now what are we adding? We adding spin. Spin is 0.5.2. Yeah, 2. So what is this? To get synchronized interior mutability, users of the standard library can use mutex. It provides mutual exclusion by blocking threads when the resource is already blocked. So when the resource is already blocked, it blocks those threads. What it does it, but our basic kernel does not have any blocking support or even a concept of threads. We can't use it either. However, there is a really basic kind of mutex in the computer science that requires no operating features, the spin lock. So mutex blocks uh, the resources which tell something is already logged, something like that. It blocks those particular threads, but our OS doesn't have threads. Our OS doesn't have blocking mechanism, so we use the bare metal version of it, which is Spinlock, which is somewhat of capable of doing this without having OS features. So instead of blocking the thread, simply try to lock it again. Oh, and again in a type loop, thus burning CPU time until the mutex is free again. I don't get it. If something is logged, like this resource is already logged, we lock it again and then again in a type loop. Oh, it blocks the thread, not the actual resource. It blocks the threads. It doesn't block the thread, it locks the thread in a loop that is locking it again and again. It is not blocking it. Yeah, that fixes it, but it uses CPU. User spinning mutex, we can add the spin crate as the dependency with the data. Then we can use the spinning mutex to add safe interior mutability in our static writer. So yeah, let's introduce mutability in our writer. It's like you know me now. Spin mutex and yeah, here we implemented that. So now, should I ref over here and wrap writer with a generic of writer. Sorry. You wrap writer in a mutex generic. It takes writer as generic. Oh, it's bad. Don't tell me someone can be that dumb. And mutex new. When you wrap it, you wrap. I'm just wrapping all of this. So it's all the wrappers. So yeah. Now it's more clear. What it does is, guys, we need to just wrap. We wrap this static inside lazy static, and now we use not the writer as the input. We wrap it inside mutex. Mutex takes the writer as generic, then use It's in its implementation. And then it returns a new what? What does it returns? Normally returns a class. What is that? Now we can, if it's an object, right? It returns an object. Most probably, someone clarify this. Now we can print something. Should I Google this? But I guess it's out of the scope, or it must be understood. It must be understood from this. I'll Google it sometime later. Now we can delete the print something function and print directly from the start function. Ooh, this piece of crap is unnecessary now. We'll just go to a start function, so we don't use this now. Just delete all of this. Now you can use the create right here. Now use core. Uh, oopsie, oops, sorry. Use core fmt and then right. From this we access the VJ buffer. We call the writer, and from that, sorry, we just create the writer. From this we call the lock. This most probably logs the thread it's blocking shit. Now we use the write string function directly, write str function, which wraps the write string function. Like hello again, and it unwraps. So our our write str function gets an okay and an error for the result type, which is write str. Now we can use the write macro. And it gives us a VJ buffer, right, dot lock again, and now we can just write this stuff. Really, 42 1.37. Oof, what did I do? 1.377 dot unwrap. Ah, so oops. Now we loop it because we don't want it to return something. The dangling function. We need to import the FMT, right? Trade in order to, yep, I get it. So it should work now. This is it. Would it build? It did build. Would it run? That's the shocking part. We can't run it because we look select a version from the required lazy statics equals to 1.8. Let's see lazy static. Will it work? Yeah. Oh, this failed. The canary version found which didn't match. Ah, did we wrote something else? Oh, there was no 8. It was 0. There's no version like that. Of course, it's small. Oops. What the fuck is wrong? What the fuck is actually wrong? I implemented before, still throwing an error. So don't initialize this over here. Just do it. See if it works. Unuse import. We didn't use it. It's still throwing an error. Running January 1 but not compiled. So there must be some kind of error to safety. We only have a single unsafe block in our code, which is needed to create a buffer reference pointing to this. Afterwards, all operations are safe. First, uses bound check for Alex. This is by default, so we won't actually write outside the buffer. Thus, we encoded the required conditions in the type system, and we are able to provide a safe interface to the outside. Uh, so I actually need to write this over here because this part uh, didn't save the VG buffer. Oh, it doesn't know where VG buffer is. Oh, it knows VG buffer is. We have initialized it. Yeah. Sorry for that. Our code is not even compiling. Using this right, man. It comes from the core library. So we are using that. What's the error, man? We did import in this one. It's the same, total same. We're actually using this, but it's not in accounting for we are using it. It says unused import. If you just delete it, for example, if I delete it because why not? Still says we have an unused one is in D. Sorry for that. Error is in the VG buffer code, not this one. In the VG buffer, it says that it is unused. We don't use it. So let's delete it from here. Yeah, sorry for that. Whoa. I got it. I got it. Yeah, we should read some. I really forgot to read the error messages. I'm still done for that. Let's go to the safe. Let's go to the print ln macro now. So yeah, we'll do this. We'll do the hard stuff now. We'll use the print ln macro, and yeah, maybe yeah, we are so close to the end. How much time did we give to this? It's not. It's crazy. We are short, so efficient with our time. Now that we have a global writer, we can add a println macro that can be used from anywhere in the code base. Rust macro syntax is a bit same, so we won't try to write a macro from scratch. Instead, we look at the source of println macro in the standard library. It says macro export, macro rules, println this. So println uses print, and for all the arguments, it is printed with format arguments this and in an essential. You know, macros are defined through one or more rules similar to match. The println macro has two rules. The first rule is for invocations without arguments. Example println, which is expanded to print and thus just prints a new line. The second rule is for invocations with parameters such as println hello or println number. This is also expanded to an invocation of print macro, passing all the arguments and additional new line at the end. Yeah, put it over here. Passing the arguments in the print, but it didn't give it at the end, it gave it at the forefront. Yeah, so the macro export attributes make the macro available to the whole crate, not just the module. It is defined in and the external crates. You can use this. This comes under the core, I guess, what's already given to us by the core. Sorry for that. It also places the macro at the at the crates root, which means we have to import the macro through use std println. Oh, instead of the std macros println, but we don't have the std. How would we use it? The print macro is defined as this is this. So now we can access the print crate IO input output, and then it uses that print and passes the format arguments. The macro expands to a call of the print function in the IO module. The crate variable ensures the macro also works from outside the std crate by expanding to std when it's used in other crates. What does it mean? The crate variable ensures that the macro also works from outside the standard crate by expanding to the standard crate when it's used in other crates. I have to read it again, sorry for that. Macro expands to a call of print function in the IO module. The crate variable ensures that the macro also works from outside the standard crate by expanding to extend to standard when it's used in other crates. Does it mean we no need to use standard crate then? Format arguments macro builds a FMT arguments type, structured arguments type from the passed arguments. So this is the argument type which is passed to the print. Print function of the library standard calls print2, which is rather complicated because it supports different std out devices. We don't need that complexity since we just want to print to the VJ buffer. To print to the VJ buffer, we just copy the println and the print macro, but modify them to use our own print function. Just use them. Let's use them. Let's explain it over here. Macro and then export. Now we have the macro rules section. I will do something like this. Macro rules print, and now it wraps with this dollar sign allows us to uh, use the std in the whole what it allows to do. Yeah, there was something like the dollar crate variable ensures that the macro also works from outside the standard crate by expanding to standard when it is used in other crates. So I guess so arguments is a variable that we know. Yeah, we explicitly know. This is too darn tough for me. Understood this part, the crate, and it gives us VJ buffer. It gives us print and we can pass the arguments now. And here comes another level of wrapping. This defines a print function. Sorry, this defines a print function. Now we need to do the exact same for the print element. Copy this and this is for the print element. Here, for an empty, we just call a print with no arguments and just the next line operator. Create, create, and then call the print macro, and then just put in simple. This should, and we can just call it directly now. Yes, looks clean. But inside the arguments, you have to first pass, uh, first pass the, and then the next parameter is the argument. Yeah. So we have now created the print function, the print element function. Now we need to, what's this? One thing that we changed from the original println definition is that it prefixes the invocation of the print macro with create two. This ensures that we don't need to import the print macro too if we only want to use the println. Oh, so we don't need to import the print macro. So if we want to use println now, cause of create, we don't need to call print again because now it's switched to the standard as this allows some sort of magic. You don't need to get too deep in that. Doc, hidden, function, print, arguments, empty, arguments, use calls, empty, and then write dot log dot write. Sorry, write fmp, and we pass in the arguments. And we call on that. Why did you call on that? Is it also doesn't right? What is doc hidden? Like in the standard library, we add the to both macros to make them available elsewhere in the page. Whether this note that this places the macros in the root namespace of the page. So importing them via this does not work. Instead, we have to do this create print element. Okay. The print function looks our static writer and calls the write fmt method on it. This method is from the write trait, which we need to include. It did. Additional unwrap at the end panics if the print isn't successful. But since we always return OK in the write SPR, that should not happen. Since the macros need to be able to call print from outside the module, the functions need to be public. However, since we consider this is a private implementation detail, we add the doc hidden attribute to hide it from the generated documentation. Oh, so as we want to use this uh, print function inside all our inside, not inside by our all our modules. So we're passing it through the core, but as the code is exposed during the documentation, we need to hide it from others. So that's why we use documentation hidden macro or the attribute. Now let's do hello world using println. Let's use our println. Let's use it. So go main eyes. Let's just delete all of this. Or kind of like all the code below. See new function. Pub extend to C, and now the function start. The dangling pointer, dangling function, sorry. We use println like you do, and call the hello world. Would it work for those world? But this is for I don't know. And here we call it let's do for this. What is this? Note that we don't have to import the macros in the main function because it is already linked in the root name. As expected, we now see a hello world on screen. What is this for? What is this for, man? It's getting messy with this cargo build. The build fails tragically. There's so much errors. There's so much errors. Oh my god. Machine fragment specifier. Fragment specifier must be provided. Let's see, they will give it a type or some kind of thing. We wrote unsafe code. We wrote unsafe code. Let's run this again. Where's the old code? Oh, we did roll unsafe code. What was that? What was that? What was it? What was it? Something flashed on the screen. We ain't printing something like that. We're just printing hello world. Why it's still printing that? Uh, why it is still printing that? I need to remove it completely. This comments not work on our ID now. There's some kind of error, man. The hello world is not working for us. Why did it happen? Why did it happen? I guess I still fucked up. I somehow fucked up this start function. Also. I guess that's the main issue. Let's run it. Why is it happening? As expected. Who expected that? It's not expected. Not even getting an error. So for some case, it's not even considering. It's building super fast. What is happening? Let me fix it. So there was some problem with the structuring of the code in our VJ before. I just fixed it. I just wrapped this inside. Uh, this is poor code structuring that was causing issues. So now it's all right. It is pending. That's the part one. It's University Hello World. Yeah. And it is. I have also used this in the panic function, but there is no panic. So yeah, we now insert panic in our start function. So yeah, let's use the panic. Yeah, let's use panic now. Not panic. What do I do? Some panic. Panic. And call this here. Cargo build. Unreachable expression. What? Which? I don't know what. Just go hello world and nothing. I don't have. Or we just break it. Oh, there's no loop, so it's causing some shitty, some shitty. It's the error now. Yeah, it's not even building for us, right? It is saying this is an unreachable expression. However, right after panic is unreachable, thus we can add this. And add this here. Then it works. Why is it going in error? Oh, here it is. Stop. Yeah, I know this. But also, it still builds. It still builds, but it says there is an error. But it doesn't print an error. Why? Are we not handling it properly? The we are handling it very nice. It's the error. A pendulum function is very shady. It's just it's what's wrong. Print is the same. We pass in the arguments. We specify print. Yes, I did. Yeah, I did it nicely as well. It's just stupid. didn't even build it. It's the main issue. Whatever it's doing, it's not doing. It's you guys again. Yeah, so I GPT'd some code and it kind of bugged off. So now it works. I GPT'd it and it removed the const over here. Like, let's plot. Let's see if I can find it. Oops. Yeah. So this guy, I know the reason I forgot where the cons the main RS was to do that. Figure it out. There's not even number ones. So yeah, you need to add this to get this running. It wasn't even compiling for me. If you add const fn new, it does. The reason I forgot to add this to the main element took me a while to figure that out. At first, I said, the fonts will be considered for the code is used with the content fonts, having divided the fonts, which is equal to the function from the RFC, this is constant, constant, but that doesn't make understand the concept behind the constant. Mine works, but mine works. Just cargo build it, then I ran the code, and now we have this and this. So this is not running hello because I removed it. This. Alan, hello, hello, world, and status. Let's compile the. Um, let's see. It's not printing. It's uh. So we need to add it. We need to add. The, so let's we need to add it on the top. Actually, where do we add it? Will it work now? Huh. There are a lot of cheeky errors. I don't know what's wrong with this. Right, cargo build. These are no errors. Right, cargo run. No, it's only do some. But it doesn't print me. For example, if like one one changes, could use yeah, it's the old build. Build is failing somehow. One unreachable expression. Root. I don't know. It worked, but now it's not working. So I did nothing. I did nothing. I just changed this panic function to use print, not print ln, and somehow it fixed it. No, it fixed it. Like just build this now. and I just cargo run. It now works perfectly, and let's see if I can change something on reflex to single edge. I guess our print function is not that good. Most probably, yeah. Our print island is not that good at printing panics. And I got this from like this implementation. Look at this implementation. It still doesn't work for us, right? The cargo image. Why is ours printed to the next line and it's not over here? It first prints the panic and then prints the panic app. Is it cause of this, or is it our panic implementation? Whichever of you. It's all the same. I just copy pasted these, right? Oh my. When we do this, build again and again. So I guess we didn't update the image for this. Choose the print again now. It's all the same. I guess we didn't update the image. Should be there's a PR or something like that for this. It's print a hello world, panic dad, da 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 da. Some panic. So we have completed this. Let's not just extend this and not waste another minute. So what was the summary of this blog post? In this post, we learned about the structure of the VJText buffer and how it can be written through the memory mapping at the address. We created a Rust module that encapsulates the unsafety of writing to this memory map buffer and presents a safe and convenient interface to the outside. Thanks to Cargo, we can see how easy it is to add dependencies on third-party libraries. Two dependencies that we add are lazy static and spin are very useful in OS development and we use them in more places in future posts. Oh, so the Tom is not going to get heavy yet. It's next. The next post explains how to set up Rust built-in unit test framework with build test now. It's nice. We'll then include some basic unit tests for the VJ buffer module from this course. So let's meet another day. I guess we will see another day. I hope that hopefully we will see another day. And after for that, it's bye. How do I end it? Bye. Bye. Subscribe. Bye. Fifth time I'm saying bye.